Hello, everyone. Let's begin today with one of the most fascinating groups in organic chemistry, the carboxylic acids. These compounds were among the earliest discovered, and their names carry stories from nature and history. Imagine the sting of an ant bite. That sharp sensation comes from formic acid, written as HCOOH. The name, formic, actually comes from the Latin word formica, meaning ant. When you smell vinegar in your kitchen, that's acetic acid, formula CH3COOH, whose name comes from acetum, meaning vinegar. Even rancid butter owes its smell to butyric acid, CH3CH2CH2COOH, derived from the Latin butyrum. These names remind us that chemistry is not just about formulas on paper but about real experiences from nature and daily life.
Now, let's step into the systematic world of IUPAC nomenclature. Here, we start with the parent alkene and replace the final E with OIC acid. Importantly, the carbon of the COOH group is always carbon number 1. For instance, methane becomes methanoic acid, which is HCOOH, while ethane becomes ethanoic acid, written as CH3COOH. If the chain has substituents, numbering always begins at the carboxyl carbon to give the lowest locants. This ensures uniformity so that chemists across the world can immediately identify the structure behind the name. Picture the structural diagrams on screen as I say this. Methanoic acid is the simplest, while ethanoic acid is one carbon longer and the very same acetic acid we encounter in vinegar. What happens when a molecule contains more than one COOH group? Then, the naming extends by using prefixes like the, tri, or tetra before the term carboxylic acid. For example, HOOCCOOH is called ethanidioic acid, commonly known as oxalic acid. Another example is HOOCCH2CH2COOH, named butanoic acid or succinic acid. These names directly tell us how many carboxyl groups are present and where they are located in the chain. You might recall oxalic acid from plants like spinach, which makes your teeth feel slightly gritty. Succinic acid, on the other hand, plays a role in the metabolic Krebs cycle. So, these systematic names not only classify but also connect to biology and everyday life. When several functional groups compete in a molecule, which one takes priority? The carboxyl group always wins. In the priority order of functional groups, COOH is supreme. Other groups such as hydroxyl, keto, or halogen are treated as substituents when COOH is present. Each carboxyl group's position is specified with Arabic numerals. For instance, a benzene ring with carboxyl groups at positions 1 and 3 is called 1,3-benzene-dicarboxylic acid, also known as isophthalic acid. Look at the skeletal diagram on your screen. You can see how numbering ensures clarity. This rule simplifies naming so that no matter how complex a molecule looks, the COOH group always anchors the nomenclature. Even with these systematic rules, many acids are still better recognized by their old, common names. For instance, formic acid is the trivial name, while methanoic acid is the IUPAC name. Acetic acid is more popular than ethanoic acid, especially in kitchen or industrial contexts. Butyric acid corresponds to butanoic acid, and oxalic acid is ethanidioic acid. These dual identities can be confusing, but they're also fascinating because they reflect how chemistry grew from everyday experiences into a systematic science. In exams and formal writing, IUPAC names are always preferred, but as a practicing chemist, you must be comfortable with both systems. Let's now try a naming example together. Consider the compound written as CH3 twice, CH, CH2, COOH. Step 1. Identify the longest chain containing the carboxyl group. That gives us a 4-carbon chain, so the parent name is butanoic acid. Step 2. Check the substituents. At carbon number 2, there is a methyl group. Step 3. Combine everything. The final name is 2-methylbutanoic acid. Always remember, the carboxyl group must be part of the parent chain and can never be considered a substituent. This step-by-step method works for any branched carboxylic acid. So, to sum up, carboxylic acids can be named either by their traditional common names rooted in history or by systematic opaque names that leave no room for confusion. The rules are simple. Replace E with OIC acid, number the carboxyl carbon as 1, use multiplicative prefixes when there are several groups, and remember that COOH always has the highest priority. I hope today's session has shown you how nomenclature is more than memorizing names. It is a language of chemistry that tells us about structure, origin, and even biological importance. I'll see you in the next class with another exciting dive into the chemistry of carbon compounds, the rules for naming carboxylic acids. Their common names often end with IC acid and come from natural sources, while the IUPAC system replaces the E of alkanes with OIC acid. Compounds with more than one carboxyl group use prefixes such as the or tri. The carboxyl group always takes priority over other substituents in numbering. Finally, many acids are known by both traditional and systematic names such as formic or methanoic, acetic or ethanoic. Together, these rules ensure clarity whether in daily use, industry, or examinations.